Yeah. So last class we have seen the analysis using D flip-flops. Now we'll see the analysis using JK flip-flops. Okay, so a little bit different thing. So compared to D flip-flop, so the analysis using JK flip-flop and T flip-flop is little bit different. Okay, so we'll see what is the difference here. Okay, so take down this diagram. So analysis using JK flip-flop here. So take this diagram. So let me know once you're done with this diagram.
Yeah, sir.
Yeah. So first of all, what we have to do in case of analysis, so we have to find the state equations. Okay. So state equations has to be found from the circuit diagram. So from the state equations, okay, so we have to find the state table. Okay, so state table is nothing but it is a combination of present states, inputs, okay, next states and outputs. Okay, so that is nothing but the state how the state table will be. And next we have to draw the state diagrams. So state diagram will mention all the list of possible states and all the list of all possible transitions and the possible outputs. Okay, so that is about the state diagram. So analysis part will always have the diagram. Okay, and first of all we have to find the state equations based on the diagram here. Okay, and after finding the state equations, what we'll do, we'll draw the state diagram. Okay, we'll draw the state diagram here. Clear?
Yes, sir.
Yeah,
Okay.
sir.
Okay. So 1 minute. Yeah. Okay. Yeah. First of all, find the state diagram here. Okay. So find the state diagram. Okay. So when we find the state diagram, so what happens here is, so from the state diagram, so what we have to find out here is, so we have to find the state equations here. So you can check the state equations. So this is the A flip-flop and this is the B flip-flop here. So I'll name it as A, I'll name it as B. So what I have to find out here is A of t plus 1 and B of t plus 1. Okay, unlike D flip-flop, so here we have to find the outputs and inputs also here. So coming to A of t plus 1, so what will be the value here? So we can't find the value here because we have the in D flip-flop. So what is the D flip-flop here? So Q of t plus 1 output is equal to D. Okay, so what are the input? So that will be the output. Whereas in this case, so we can't tell what is exactly Q of t plus 1. So Q of t plus 1 is a characteristic equation is equal to, so J Q bar, okay, plus K bar Q. So that is the characteristic equation. Yes or no?
Yes, sir.
Yes, sir.
Now we have two flip-flops here. So what I can write here is J A bar plus K bar A. So that will be the characteristic equation. So first of all, what I have to find out here is, so we have to find the value of J and K here with respect to A and B flip-flops. So what I can name here is, I'll name this as JA, I'll name this as JB, I'll name this as KA, and name this as KB. Okay, so first of all, I find the values of JA, KA, and JB, KB, and I'll substitute these values, and then I can get the A of t plus 1 values here. A of t plus 1 and B of t plus 1 values. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
So from this, what is the value of JK here? So this is, I'll find it as J suffix A. Okay, so this will be JA Antano. So this is JA here. So JA is the values we are getting from. We are getting from B here. So JA is equal to B, and we can see the K here. I'll name it as KA.
Sir,
So
some are waiting,
KA.
sir.
1 minute. Okay, I'll name this as KA. So KA is equal to, so under operation of, what are those values? So we have under operation of this B value, and what are other value? X bar value. Okay, so X bar B or BX bar. Yes or no?
Yes, sir.
Okay, so this is the values of JA and KA. And tell me the values of JB and KB. Tell me the values of JB and KB. This is JB. So what is the value of JB?
Bar, sir.
X bar, sir.
JB is equal to X bar,
X
and
bar.
KB is equal to what is the value of KB? It is exclusive or of operation of
Yes, sir.
XOR A, sir.
of X here.
Yes.
A exclusive or of X.
X, sir.
Okay, so these are the equations of JA, KA, and JB and KB. Okay, so this is the first step we have to do. So we have to find the state equations here. So JA, KA, and JA is equal to B here. So KA is equal to BX bar. So JB is equal to X bar. Okay, so KB is equal to A exclusive of operation A bar X plus AX bar. Okay, so these are the equations here. So next we have to find the state table. Okay, so we have to find the state table. So what does the state table consist of? It should consist of the present state. The present states are nothing but A and B. Okay, so present states should consist of A, B, and we have only one input, that is X. Okay, so next states E of t plus 1. Okay, and so B of t plus 1. Okay, so A of t plus 1 and B of t plus 1, and so this is the first case here. So we don't know how to find the values of A of t plus 1 and B of t plus 1 generally. Okay, so we have two methods to find out here. The first method is, so using the truth table. Okay, second method is using the equations, characteristic equation. Okay, so I'll let you know the first method here. So this will be the, wait a minute. Okay, we have to derive the state table here. The state table should consist of these values. So present state, what are the present state values? A and B, capital A and B. Okay, so and input. So input is equal to, inputs are X. We have only one input here, that is X. Okay, so present state is like 0, 0. And a three input combination, I mean three combinations here. So 0, 0, 0 to 0, 0, 1. 0, 0, 1, 0, 1, 0, 0, 1, 1. and 100, 10,
1,
One.
and 110,
111.
full one.
One
Okay.
10.
In case of D flip-flop, so whatever the inputs we take here, so that will be is equal to output. So we don't find any problem in case of D flip-flop here. Okay, so we don't find any problem in case of D flip-flop. Okay, so in case of D flip-flop, what we'll do here is, so A of t plus 1 and B of t plus 1 is equal to D. Okay, A of t plus 1 and B of t plus 1 is equal to D. So that is what we used to take in case of D flip-flop. So whatever the equations here, so whatever the input equations we got, so the substitute those values in those equations, and we used to get the values here. But here the main problem is this is next state. Okay, so next state we don't have values of A of t plus 1, t plus 1, and B of t plus 1. Okay, so we don't know the values of A of t plus 1 and B of t plus 1. We have to find the values of A of t plus 1 and B of t plus 1 here. So for that, what we'll do here is, so we'll take the help of flip-flop inputs. Okay, so this is not part of the state table, but this is one of the method. Okay, so this is one of the method. So to find the values of A of t plus 1 and B of t plus 1. Okay, the flip-flop inputs. So what are the flip-flop inputs we have here? So we have JA, and we have KA, and we have JB, and we have KB. Yes or no?
Yes, sir.
So we have this equation. So what we have to do, we have to substitute these values of ABX into the equations of JA, KA, and JB and KB. So what are the values of JA? What are the values of JA?
B.
B.
What are the values
0.
equal to B? Okay, so JA is equal to B. So what are the values of B? So we'll be writing the values of B here. So it is nothing but 0, 0,
0. 1.
1, next
0.
0, 0,
0.
1.
1. 1.
So these are the values of D. What is the values of K? So B X bar. So what is the values of B here? So what are the values of B? What are the values of B X bar? So B X bar, so we have to take the values of B X bar here. So B is 0, X bar is 1 here. Okay, so hence, even though we'll get a 0. Okay, so B X bar 0 into 0, it's a 0. So B X bar 1 into 0 bar, it's a 1. Okay, so 1 into 1, it's a 1. So 1 into X bar, so that is a 0. Okay, so 0 into X bar, that is a 0. So 0 into X bar, that is a 0. So 1 into 0, that is a 1 here. I mean 1 into X bar, that is a 1 here. So 1 into 0, it's a 0. So that is a value. So no.
Yes, sir.
Yes, sir.
Okay. So we know the truth table, right? So with the help of truth table, so what we'll do here is A of t plus 1 is, with the help of JK values, we'll find the values of A of t plus 1. We'll find the values of A of t plus 1. So what is 0, 0? What is 0, 0? When J values are 0, 0, what happens?
0, sir.
0, sir.
Why 0? Why 0? So general JK value 0, 0 అయితే ఏమవుతుంది మనకి ఏమొస్తుంది?
No change state, sir.
No change state. So no change state, I mean it will remain in the previous state only. So previous state is A. So previous state is A here. So what is the value of A? 0.
0.
0, sir.
So hence it is a 0 here. So next JK value is 0, 0 ante, it's again the previous state. So that is equal to 0. And JK value 0, 1 and 1, 1 ante. So 1 1 into what is the output we'll get here? So JK values is equal to 1 1. So what is the truth table we'll get?
A bar, sir.
A bar. So A bar is 0 here. So A is 0, A bar is 1. Okay?
Yes, sir.
Okay. And 1 0 is there?
1,
One, sir.
If it is 1 0, irrespective of present state here, so in respect to the value of A, it is equal to 1. And 0 0 is there? It's the previous state. So previous state is A here. So A is 1. And 0 0, it's again 0 0. Its previous state is equal to 1. And 1 1 is a toggle of the previous state, 0. So 1 0, it's
One.
a. Okay. In a similar way, we'll find the values of JB and KB. Okay. So tell me the values of JB and KB. Substitute those values. JB is equal to X bar. So what are the values of X bar here? So we'll take these values. X 1 0 1 0
0,
1 0
1, 0.
1 0. So that is the value of X bar and KB. So this is the value of KB, right? Yeah, 1 minute. This is equal to KB. Okay, so KB is equal to A x to 0 of X here. So 0 x to 0 of 0, it's a 0. 0 x to 0 of 1, 1. 0 x to 0 of 0, it's a 0. 0 x to 0 of 1, it's a 1. So 1 x to 0 of 0, it's a 1. And 1 x to 0 of 1, it's a 0. So 1 x to 0 of 0, it's a 1. And 1 x to 0 of 1, it's a 0.
0.
So it's nothing but A x to 0 of X here. So A x bar plus A bar X. Okay. So with the help of KB and JB and KB values, we'll find the values of B of T plus 1. Okay. So what is the value of this one? JB and KB 1 0. So 1 0 అయితే ఏమొస్తుంది మనకు? What is the value of B?
1, sir.
1, sir.
1, sir.
It should be fast. Right. So 0 1.
0.
0, sir.
Next 1 0.
1, sir.
And 0 1.
0.
0. So 1 1 toggle of the previous state. So toggle of the value of A here.
1,
So
sir.
A value is 1 here. So toggle is 0. So I mean line lo undakochu, but take the values. Fifth value. So fifth value is 1 here. Sorry, B kada? Yeah. Sorry. So B is 0. We'll get a 1. Okay. And next 0 0.
0, sir.
0.
Yeah, it's the previous state 0. Okay. And next 1 1.
0, sir.
All of the previous state it says 0. So 0 0
1,
is
sir.
a previous state 1. Okay. So this is one method here. So there is one method how to find the state table here. Okay. So this is one of the methods. Okay. So you can verify this. This is one of the methods. So with the help of flip-flop inputs, we'll find the next state here. So this is one of the methods here. Okay. So there'll be another method. So the another method is like this. So how we can find here is with the help of characteristic equation. Second method. Okay. So characteristic equation. Okay. So what is the characteristic equation of JK flip-flop? So A of T plus 1 will be this. A of T plus 1 is equal to, so JA okay. So J, what is the output I'll get here? So JA bar. So J into this one, right? So generally J Q bar plus K bar Q.
Excuse me, sir.
Yeah.
Someone is waiting, sir.
No one.
Okay, sir.
No one is waiting actually. Okay. Yeah. So J Q bar plus K bar Q. So with respect to A, it is J A bar. So I mean, we present state if I take it as A here. Okay. So J A and A bar here plus K A bar and A. Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So with respect to A, what is the value of J A here? B here. Okay. So J is equal to B, A bar. Okay, so Q is nothing but A. Okay, in the diagram you can see there, instead of Q, what I'm taking here, it will be, you are taking it as A here. Okay. Plus what is the value of K? It is BX bar 4 bar. This is another method. BX bar, 4 bar into Q. Q is nothing but A. Okay. What is that I'll get here? So A bar B plus, so Bx bar 4 bar, and it's a De Morgan's law. So what we can write here? So B bar plus X, okay, into A. So into A in the sense, what I can write here? A bar B plus AB bar plus AX. Yes or no?
Yes.
Yes, sir.
So this is the value of A of T plus 1. In a similar way, so we'll write the values of the second method. So B of T plus 1. So what I can write here? B of T plus 1 will be like this. B of T plus 1 is equal to, sorry, JB. So that is, I'll write it as small here. So JB into B bar plus KB into B. KB bar into B here. Okay. So the value of B is nothing but Q here. So J Q bar. So J Q bar plus K bar Q. So that is the equation of JK flip flop, right? Okay. So this is the value of JB here, and this is the value of Q. Q is nothing but B here. Okay. So substitute these values. So JB and KB values. Okay. So in this, and we'll find the equation. So that is another method. Okay. So first method is where we'll find the flip-flop input equations. We'll find the values of flip-flop input equations, and based on these flip-flop input equations, we'll find the value of A of T plus 1 and B of T plus 1 using the truth table. Okay, using the truth table.
Yes, sir.
Okay, and second method is we'll find the characteristic equation and substitute these values, the values of JA, KA, and JB, KB, and the values are substituted in the characteristic equation, and we'll find the values of A of T plus 1, B of T plus 1. That is the second method. Okay, you can prefer any one of them. Okay.
Yes, sir.
Okay. So that is the first thing here. So now we are done with the state table here. Next we'll go for the state diagram. Okay. So how many number of possible states are there here? How many number of possible states are there here?
4, sir.
4. Yeah. So 0, 0. So only look at the present states here, not inputs here. 0, 1. So 1, 1 and 1, 0 and 1, 1. So these are 4 possible states, and we have 1 input here, and these are the next states. Okay. So draw the diagram for this. Draw the diagram for this. Okay. So diagram will be like this. So 4 states. We stored all the possible 4 states here. It says 0, 0. We can take like this 0, 1, 1, 0, 1, 1. Okay. If from 0, 0, okay, if x is equal to 0, we don't have any outputs here. If x is equal to 0, it will go to the state 0, 1. Okay, it will go to the state 0, 1. From 0, 0, if x is equal to 1, it will remain in the same state. It will remain in the same state. Okay, and from 0 1, if input is equal to 0, it will go to the state 1 1. Okay, sorry, it's a 1 0, right? So 0 0 0 1, if input is 0, it will remain in the same state if input is 1, and from 0 1, it will go to the state 1 1 if input is 0. What is 1 1 state here? So this is 1 1 state if input is 0. If input is 1, it will go to state 1 0. If input is 1, it will go to the state 1 0. Okay, and from 1 0, if input is 0, it will go to state 1 1. From 1 0, if input is 0, it will go to the state 1 1. If input is 1 year, it will remain in the same state 1 0. If input is 1 year. Okay, and from 1 1 state, if input is 0, it will go to state, it will go to state 0 0. Input is 0. If it is like 1, it will remain in the same state. Clear? So we can draw it in different ways. So we can take here 0 0, ikkada 0 1 తీసుకోవచ్చు, లేకుంటే ఇక్కడ ఇది తీసుకోవచ్చు, but we should follow some order here. Clear?
Yes, sir.
Yes, sir.
If we are taking the values like this 0 0 0 1 1 0 1 1, so I'll get the equation like this. Just the things should be mentioned in a proper way. Okay, so and if I substitute the values like this, so a of t plus 1 is equal to, these values are substituted, so I'll get these equations like this. Okay, the substitute chesam kada, so I'll get the equations like this. A of t plus 1 is this value. Okay, so we got these equations, right? So and b of t plus 1 is this value. Okay, so there is another method of finding the a of t plus 1 b of t plus 1. Substitute the values of a bx into this, we'll get the values of a of t plus 1 b of t plus 1. Other method is, we have seen that, so with the help of flip-flop input equations. Okay, so take down this diagram. Take down the diagram. Done? Yeah.
Yes.
So this analysis part, right? So analysis ella cheyali, d flip flop tho aithe it's a different thing. Okay, so coming to this one, okay, it's a quite a different one here. Okay, so we have two methods for this. We'll see another method when we are using the t flip flop. Okay, so we are dealing with the t flip flop, so we'll see a different method for that. Okay,
Yes, sir.
so next analysis using t flip flops. So take note this diagram. So take note this diagram. Next one is analysis using T flip flop here. So this one is analysis using T flip flops. So we'll see another method, so which is a characteristic equation method. Done?
Yes, sir.
Okay. First of all, find the state equations. State equations. Okay, so state equations, so the value of, we don't know the values of a of t plus 1, so what I can find here is ta. So ta, what is the value of ta here? It is x into b. Okay, x into b. And what is the value of tb? So tb is equal to, so we have the value of tb as x. Okay, so tb is equal to x here. Okay, so these are state equations here. Okay, and we have one more expression here, y here, so which is output equation. Okay, so these are the inputs here. Okay, and this is output. Okay, so output is like y. So y is equal to, so what is the value of y?
AB, sir.
A into b. Okay, so now we will find another method in order to find the a of t plus 1 and b of t plus 1. So the method is like characteristic equation. So generally q of t plus 1 is equal to, what is q of t plus 1? Characteristic equation of t flip flop, p exclusive of q. Yes or no?
Yeah, sir.
Okay. So now we have a of t plus 1 is equal to, what is the value of ta here? So ta XOR of ta XOR of a. Okay, and b of t plus 1. So pb XOR of b.
Yes, sir.
Okay, now what we have to do here is we have to find the state table. We'll find the state table here. Okay, a state table. State table. So present states, input. Okay, so present state is like a, b, and input is like x. Okay, so write the values from 0, 0. right? So these are the values from present state and inputs here. Okay, and next we'll be having so next state is t of a of t plus 1, and so a of t plus 1, b of t plus 1. Okay, and we have output that is y. Okay, output that is y. Substitute these values here. Substitute these values. So is it visible?
Yes, sir.
You can please clear. Yeah. Substitute these values. So what is a of t plus 1? A of t plus 1 is equal to a of t plus 1 is equal to ta into XOR of a. Okay. So what is the value of ta?
X into B.
So we'll elaborate the equation. So that we'll understand a of t plus 1. So a of t plus 1 is equal to, so ta is equal to x into b. Okay, and XOR operation of a here. Okay, so x into b XOR of a. So if I want to elaborate it, you can elaborate that. But what I'll do is I'll just substitute these values here. Okay, so x into b, what is x into b here? So x is 0, 0 XOR of 0, it's a 0. Clear?
Yes, sir.
No. Okay, and so what is the next value? So it is x into b. X into b is 1 into 0 is a 0. 0 XOR of 0, it's a 0. Okay. Next 1 into x into b. X is 0. B is 1 here, so it's a 0. So 0 XOR of 0 is a 0. Okay. So next x into b here. X into b is like 1 into 1. So 1 into 1 is a 1. 1 XOR of 0 is a
1.
Okay, so 0 into 0, it's a 0, 0 XOR of 1, it's a 1. So 1 into 0, it's a 0, so 0 XOR of 1, it's a 1. Okay, and 1 into 0, it's a 0, 0 XOR of 1 is a 0. Okay, and 1 into 1 is a, what is 1 into 1? So 1 into 1 will get a 0, 0 XOR of 1 is a 1. Okay, so this is the value of a of t plus 1. So coming to b of t plus 1. Okay, so what is the value of b of t plus 1 here? So b of
Sir, sir, last 0 kadandi, sir.
So bx is 1 into 1. So what is 1 into 1?
0, sir.
Sorry,
0,
1 into
sir.
1. 0, sorry, I thought it's x. Sorry. Thank you. 1 minute. Zero. Okay. You can mistake now.
No, sir.
No, sir.
Yeah. So next b of t plus 1. So what is b of t plus 1 value? So b of t plus 1 is tb into XOR of b. So what is the value of tb here? So tb is equal to x. Okay. So x XOR of b, right? Okay. So x XOR of, we have to perform XOR operation between x and b here. Yes or no?
Okay.
Yeah. So b of t plus 1, 0 XOR of 0, 0. Okay, 0 XOR of 1, 1. So 1 XOR of 0, 1. So 1 XOR of 0, it's a 0. So 0 XOR of 0, it's a 0. 0 XOR of 1, it's a 1. So 1 XOR of 0, it's a 1.
1,
And 1 XOR of 1, it's a 0.
0.
Okay, so this is the value of b here, and value of y is nothing but y is equal to a into b. So I have to multiply the values of a into b. 0 into 0 is 0, 0 into 1 0, 0 sorry, 0 into 1 0. So 1 0 into 1 it's a 0. So 1 into 0 0. So 1 into 0 0. 1 into 1 1. 1 into 1 1. 0 into 0 0. Okay, so this is the state table. So with the help of with the help of the characteristic equations. Okay, with the help of the characteristic equations. So this is what but output and mistake is
Last one, sir.
Edi
Last, sir. 111. Output y 1, sir. Danki.
is equal to a into b, kada? So what I have done is wrong here. So 1 minute.
1.
I have done a of t plus 1 and b of t plus 1. So this is yeah. Sorry. 1 minute. So it's a into b and a of t plus 1 into b of t plus 1. 0 into 0, 0, 0.
0. 0.
0,
0.
0.
0.
And last two stages are
Last 2 is 1, sir.
Yeah, sorry, mistake is like I had done a of t plus 1, b of t plus 1. It's a into b. Okay, so its last two stages are 1 1. Okay, so this is the state table here. Okay, so now I want to tell you the two differences here. Okay, so check the output here. So check the output column. So output. Okay, so output is not dependent. Output is not dependent on inputs. It is dependent only on states. It is dependent only on states. So states are nothing but A, B. A and B are states here. So y is equal to AB here. So we don't have any kind of input here. So input is not involved here. Okay. So X is not involved. It is depending only on the states here. Yes or no?
Yes, sir.
Sir.
So if like output is like y is equal to ABX, I'll say that output is depending on the states and also the inputs. Okay, output is dependent on the states and also the inputs. Okay.
Yes, sir.
Okay, so this is the case with this one. So this is the T flip-flop here. So in this example, so output is dependent only on the states here. So we don't involve the inputs here. Okay, so we don't involve the inputs in this case of this one. So what is this one? This example. Okay, earlier examples, the inputs are used with, I mean, the output, if I have any output column, so those outputs are obviously linked with the inputs here. So these are two kinds of circuits. I'll explain these two kinds of circuits, the definition of these two kinds of circuits. Okay, so meanwhile, so here output is dependent only on the states here. Okay, only on the states, and the state diagram will be different here. So what the state diagrams will be, so we having 4 possible states. So output is 1 1 for the last possible states here. So that is 1 1 ki output 1 on the remaining any states ki output 0 on the. So e kind of states ki I'll mention the outputs with respect to states here. So 0 0 kinda 0 rastan, that is the output of this state here. Okay, so 0 1 I'll write the output in this state here. So 1 0 I'll write the output here. So 1 1, so the output is 1 here. So for this state, this one. Yes or no?
Yes, sir.
Okay. So here output is related to the states here. Output is not related to the inputs here. Okay, output is not related to the inputs. Clear?
Yes, sir.
Yes, sir.
Okay, so that is the case of this. This in this case here. That is in this case. So now I have to draw the state diagram. So where we have to mention the states here. So 0, 0. If it's like 0, 1, the output is 0. So you can check here. So this is for 0, 0, 0, 1. So 1, 0, 1, 1. So 1, 1 దగ్గర మాత్రమే output 1 ఉంది. So 1, 0, it's at 0. So 1, 1, it's at 1. So for x is equal to 0, it remains in the same state. So x is equal to 0. Okay, for x is equal to 1, it will go to state 0, 1. Okay, and for 0, 1, if x is equal to 0, it will remain in the same state. And if it's like 1 year, it will go to the next state. 1, 0, if it is x is equal to 0, it will remain in the same state. If x is equal to 1, it will go to the next state, that is 1, 1. Okay, and if in state 1, 1, if x is equal to 0, it will remain in the same state. If x is equal to 1, it will go to the next state. Sorry, yeah, x is equal to 1, it will go to the next state. So this will be the diagram here. Clear? Yeah. 1 minute. Okay. This is the state diagram here. Okay, this is the state table here. Okay, so diagram will be like this one. So this is a T flip-flop here. Okay, this is using analysis using T flip-flops. Okay, so in case of analysis, what will be given here is, so will be given a diagram here. So after giving the diagram, so you have to, what you have to do, so you have to find the state equations. From the state equations, you find the state table. So D flip-flop, it's quite easy, but in case of JK and T flip-flop, we have two methods. The first method is we have to draw them, we have to find the flip-flop input equations, and based on the flip-flop input equations, with the help of truth table, we have to find the values of the next states. Whereas another case, with the help of characteristic equations, substitute those flip-flop input equations in the characteristic equations and find the values of next states here. So that is the difference here. Clear?
Yes, sir.
Okay.
Yeah, sir.
And coming to the next one here, so what we can see here is, so I told you, right, so output is dependent only on the present states, and output is function of inputs and also the present states. So those are the two models here, so Mealy and Murray models. Okay, so Mealy models and the Murray models. Okay, so those models, so the models what we discussed in the last topics here. Okay, so here, so coming to the Mealy model here, the Mealy model, the outputs are functions of the present states and inputs. Earlier I told you like y is equal to a into b, right? So instead of I get like y is equal to ax bar plus b and ankondi. So this is the Mealy model here. So output is depend on the present states and also the inputs here. Okay, output is a function of present states and also the inputs. Clear?
Yes, sir.
Yeah, sir.
Okay, and whereas output is function only on the present states, so y is equal to a, b and ankondi. Okay, so then it is a Murray model. Okay, so generally the sequential circuits can be divided into two models here. So the kind of Mealy models and the Murray models here. Okay, so diagrams will be like this. Okay, so combinational logic, the state resistors here. So the main thing is like inputs is deciding the outputs here, and you can see here the inputs are not involved. I mean, this line is not there in case of the Mori models here. Okay, so everything is fine, but inputs are not involved in the output logic here. So that is a Mori type kind of outputs here. So these are block diagrams of Mealy and Mori models here. You can take these diagrams. Clear? Done?
Yeah, sir.
Yeah.
Yeah. So this is a million Mori models. This is an example of million Mori models here. Okay. So next topic is like state assignment and state reduction. So state reduction. Okay, so we'll check the state reduction and state assignment techniques here. Okay, so reduction is nothing but reduction in number of states here. So reduction in number of states. So earlier we have seen 0, 0, 0, 1, 1, 0, 1, 4 states. If I have 7 to 8 states, and we'll check the possibility of any kind of reduction. Okay, so when the number of states are reduced, so there is a possibility of reducing the number of flip-flops used. So when the number of flip-flops is reduced here, so what we get is like, so we can reduce the cost of the circuit. Okay, so and better performance. So when a designer of a core engineer or any kind of VLSI designer or embedded system designer, what he will do here is they'll always think about the optimizations. Okay, so take your TV screen. So TV screens, earlier TV screens alone like, so earlier TV screens are like CRT. Okay, so they are huge in size. Okay, we have less clarity there. Okay, and it is difficult to carry, and the screens are very small. So in earlier days, so what happened? The technologies has been replaced there. Okay, so first we started with the LCD technologies. Now we are going with the LED technologies. Okay, so the size has become very compact here. I mean, it has become very slim. Okay, and the performance has been increasing very much here. The performance is increased very much here. Okay, so that is what a designer or engineer thinks of here. So he always thinks about the optimization in the sense, so reducing the number of circuits or reducing the size of the circuit, but the improved performance must be taken here. So that is the importance of reduction here. Okay, so clear or not?
Yes, sir.
Okay, so now we see the concept of state reduction here. So take this diagram. So take this diagram. So from this state diagram, we'll draw the state table. In that state table, we'll see how the reduction process will take place here. So take this diagram. So we have states A, B, C, D, E, F, G. Okay, 1, 2, 3, 4, 5, 6, 7. 7 states. We have 7 states here. So the concept is state reduction here. First concept is state reduction. Done?
Yes, sir.
So this is a
Yeah, sir.
Mealy model. So this is a Mealy model. So we have to draw the state table now. So state table should consist of present states, input, next state, and output. So we have all these columns here. Okay. So present states are like A, B, C, D. We have A, B, C, D, E, F, G. Okay, and so we have another kind of drawing. I mean, when we have these values are given here, the inputs are taken like this. Okay, so input says x only, we'll consume it as x here. So x is equal to 0 x is equal to 1 I'll write the inputs like this. Okay, sorry. So inputs is like x only, but what we can do here is, okay, so next states, I'll take the next states based on the inputs. So when input x is equal to 0 and x is equal to 1. For example, I'll tell you here. So A here, so A is there. So input is x here, the next state is A only. Okay. So when input is 1 here, okay. So when input is 1, it will go to the state B here. It will go to the state B. Okay. And outputs 0, 0. Okay. So outputs when x is equal to 0 and x is equal to 1. Okay, so A here, so Ax is equal to 0, it will remain in the same state, that is A here. Okay, and if it is like x is equal to 1, it will go to the next state, that is A is equal to B here. I mean, next state is B here when x is equal to 1. And outputs in both the cases, they are equal to 0, 0. Okay, the same state B here, so we'll check the value of B. So when B 0 is the input here, so we'll go to the state C. Okay, and if 1 is the input, it will go to the state D. Okay, and what are the outputs here? 0, 0. Okay, so for this B here, so 1 aithe it will go to D. Okay, 0 aithe it will go to C. So that is the case we have seen here. Okay, and what is the next case here? C here. So what is C? C 0 aithe ekkada potundi? 0 aithe it will go to A. Okay, so 1 aithe it will go to state D here. So C aithe, if it x is equal to 0, it will go to A, and if it is like x is equal to 1, it will go to D. And both the cases, outputs are equal to 0, 0. Okay, next D state. So when it is equal to 0, it will go to state E. Okay, when it is equal to 0, it will go to E here. When it is 1, it will go to F. Okay, so D state, when x is equal to 0, it will go to E, and when x is equal to 1, it will go to F here. The outputs are 0 and 1.
1.
Okay, so getting my point, so you have to write the state table like this. Yes or no?
Yes, sir.
Okay, so in the same way, you can draw the diagram here. So you can take this diagram. Okay, so you can take this diagram here. So take these diagrams, state table.
Over, sir.
Yeah, so that is from the diagram here. Okay, so that is from the diagram what we got. Okay.
Okay,
Yes, sir.
sir.
Yeah. So from this diagram, so what our concept is like, so we have to find the concept of state reduction. So state reduction can be done when we identify the equivalent states. Where to identify the equivalent states. Okay. So how to identify the equivalent states? So the states which will produce the same next states and the same outputs are said to be equivalent. I'm getting my point here? The states which produce the same next states, okay, so which produce the same next states, okay, and same outputs are said to be equivalent, okay, are said to be equivalent. So check the states. So A states equivalent చెప్పండి నాకు. Tell me the states which are equivalent here. So they should produce the same next states and same outputs.
AF, sir. EG.
A,
EG, sir.
AG. So AG.
EG, sir.
So AG. So the next state is like AB.
AG not,
G.
sir.
AG కాదు because it's
EG, sir.
A. Huh?
E, sir.
Clear చెప్పు.
EG, sir.
AG. Yeah, AG. You can see here the next state is like AB, but here we have AF here.
A not, sir. E, sir.
E. EG.
Sir. Yes, sir.
Yeah. So E, it is producing same next state, that is AF, and G is producing AF here, and the outputs are also same here. Okay, so what I can do? So E is equal to G, so I can replace the values of G with. So replace the values of G with E here. Okay, ekkada G undo akadanta E place cheyali. So then the reduced state table will be like this. Okay, reduced state table will be like this. So replace the values of G with E. So here we have G, write it as E here. Okay, and I'll eliminate this one. Okay, I'll eliminate the values of G value తీసేస్తాను. Okay, because they are equivalent. So equivalent కాబట్టి తీసేస్తాను. So the table will be like this. Okay, so EG, so we have removed this one here. Okay, so the value of G is removed, and this F low G is replaced with E here. Okay, so this is the second reduced table, and now we have any kind of equivalent states ఉన్నాయి ఇక్కడ ఏమన్నా?
D and F, sir.
Yes, sir.
Yeah, we have D and F.
F, sir.
What I can do here is replace F with D here. Replace F with D, and I can remove this F here. Okay, so take down this diagram. So e table తీసుకోండి, తర్వాత replace that. So final table will be like this. Clear? So this is the finalized table here. This is the finalized reduced state table. Okay, now we have to draw the state diagram, reduced state diagram. Okay, so reduced state diagram will be like this. So we'll be having A, B, C, D, E, F, right? So from those values we can we reduced two states here. Okay, so we reduced two number of states. Okay, So two number of states reduce అయినాయి కాబట్టి number of transitions కూడా reduce అవుతాయి. Okay, so we'll get the diagram like this. Okay, this is the final diagram. You can take this diagram. Done?
Yeah, sir.
Yes, sir.
So there is a concept of state reduction here. So when you are given the concept, like you are given a problem and you have to do the reduction process, this is the method you have to follow. You have to find the equivalent states and reduce those states here. Okay.
Okay, sir.
And state assignment. So state assignment is nothing but so assigning some binary values or any other values to this states here. So that is a simple concept here. Okay. So we have A, B, C, D, E here, right? So those values are replaced with the binary values. So 0, 0, 0, 0, 0, 1, 0, 1, 0, so 0, 1, 1, and 1, 0, 0. Okay. So that is the state assignment. So we can do kind of assignments in the gray code also. So this is gray code assignment here, and this is one hot encoding here. So where so one state is represented by 1 year and remaining all with zeros here. Okay, so most of the times we'll prefer this binary assignment only. So what we can do here is, so earlier reduced state table undi kada, so dantlo A, B, C, D, E badlu, so we are substituting the values with, so A is equal to 0, 0, 0, so B is equal to 0, 0, 1, C is 0, 1, 0, so D is 0, 1, 1, and E is 1, 0, 0. Okay, clear?
Yes, sir.
Yes, sir.
1 minute.
Yes, sir.
Okay, so this is state assignment. So assigning some binary values to the present states here. Here.
Yes, sir.
Yes, sir.
So next part is design procedure here. So we'll see that in the next class. So next class I'll be taking tomorrow and day after tomorrow, even though they're holidays. So most probably I'll not take the morning session. So I'll be taking the afternoon session around 3 to 5. Okay, and Sunday in the morning session. Clear?
Okay, sir.
So
Okay,
tomorrow
sir.
we'll use this design procedure. Design procedure, we have many problems. So we'll see how to design the circuits here. So we'll see minimum of 10 problems, okay, with the designs here. So that finishes the part of the unit. This analysis is done now. Analysis of sequential circuits is done. So Murray and medium models, we have seen that. We have seen the state equations and state tables and state diagram, state prediction and state assignment. Okay, so synthesis is nothing but design using flip-flops here. So we have to use this designs here. So designing of the circuits will be done here. Okay. The next class, 4 classes. So what are the second Saturday and Sunday, the 2 classes tomorrow and day after tomorrow, we'll try to finish this synthesis of flip-flops here. Okay.
Okay,
So
sir.
next we'll start
Yes,
this resistors and counters. So it will take around 5 to 6 classes. I mean, around 6 to 7 classes. Okay. So maybe the next week we'll try to finish this one, and this will take a last unit will take around 2 to 3 classes only. Okay. So worst case is like 10 days and 20 classes. Okay. So we'll see. Okay. So if your college reopens, we'll have the revision things also. So if anyone is having doubts, we can have the revision concepts also, and we'll see another problems related to this, any kind of advanced problems related to this one. Yeah.
okay, sir.
Okay. So meanwhile, you start preparing because this is important one subject which is important for your future classes, and if you are settling in any kind of fields, so this is the important one. Okay. So don't neglect this one. So listen to this recordings. I'll be sending the other recordings also. Recordings may be slow because the concept of problems untai kabatti. So maybe it is time taking, but you listen to those recordings patiently.
Okay, sir.
Okay. Yeah. So I'll stop it for today and see you tomorrow.
Thank you, sir.
Yeah. Thank you and have a nice day.